Okay, so picture this. It's 1911, you're a geologist in Antarctica, one of the most remote, hostile, desolate places on Earth. And you look over at a glacier and it is bleeding, like actively deep crimson red, pouring down the side of the ice like something out of a horror film. That's what British geologist Thomas Griffith Taylor stumbled upon in Antarctica's dry valleys. And his first guess was red algae, which makes a lot of sense. When you're staring at something that red in Antarctica, but what was actually happening was far weirder. Welcome back, I'm Danielle. I'm a snowflake preservation artist out of Colorado, and today we are going to Antarctica. Buckle up, let me set the scene. The McMurdo dry valleys are one of the most extreme environments on Earth. These valleys are so cold, so dry, and so swept by these intense katabatic winds, almost no snow or ice accumulates on the ground. In the middle of this alien landscape sits Taylor Glacier, a massive ancient river of compressed ice. And at its base, there's a crack. And from that crack, bright red water seeps out, flows down the glacier face, and pools below. Thomas Griffith Taylor called it Bloodfall, and the name is stuck. Now, for over a century, scientists knew it had something to do with iron. The working theory was that iron in the water oxidized. Basically, the glacier was rusting, and that's mostly right, but not the full picture. It wasn't until 2023 that researchers at Johns Hopkins finally cracked it. A scientist named Ken Libby put the water samples under a powerful transmission electron microscope and found something nobody expected: tiny iron-rich nanospheres. So small they make a red blood cell look gigantic, and they're not like any mineral scientists expected to find. They oxidize the instant they hit oxygen. The moment that the water touches our atmosphere, bright red instantly. Rust. This is the part I find the most fascinating. When this water comes out from under the glacier, it's actually clear, completely transparent. The red only appears on contact with the outside world. Like the glacier is saying, I have been in here for a very long time, and now I'm reaching to you. So where is this iron? About 400 meters beneath the surface of Taylor Glacier, that's roughly the height of the Empire State Building, there is a subglacial pool of ancient salt water. And not just any salt water. Scientists believe this water is a remnant of actual ancient seawater from around 5 million years ago, when the dry valleys were fjords. Ocean water filled these valleys, and then over millions of years, as temperatures shifted and glaciers advanced, that seawater got trapped, sealed, and buried underneath hundreds of meters of ice, and it just stayed. That sealed pocket has been isolated for at least 1.5 million years. No sunlight, no fresh air, almost no oxygen, just ancient saline, about 3 times saltier than the ocean, sitting in total darkness, rich with sulfate and iron, slowly leaching from bedrock below. And here is what completely stops me. It's not empty. Microbiologist Jill Minkuski made blood falls essentially her life's work. Multiple expeditions, years of Antarctic field work just to get her hands on a clean sample of the water. When she finally did, what she found inside was a whole community, more than a dozen distinct microbial species, alive, living in the dark, in ancient oxygen-starved saline water, potentially for millions of years. And not only are they surviving, they invented a completely new way to make energy. Most life on Earth uses oxygen. These microbes don't have that option, so instead they use sulfate and iron in coupled chemical cycles. A metabolic system science has never documented anywhere on Earth before this. The iron from the bedrock acts as a catalyst. They reduce the sulfate, react it with the iron, and cycle it back over and over. A closed loop running in the dark under a glacier for longer than modern humans have walked this planet. Scientists literally said this is unique, as in we didn't know life could do this. And these microbes, genetically, they trace back to ancient marine bacteria, because they are ancient marine bacteria. They're the descendants of ocean life that got sealed under a glacier millions of years ago and just adapted. Now here's where it gets big picture. Jupiter's moon, Europa, has a vast liquid ocean sealed beneath miles of ice. Saturn's moon is actively shooting geysers of salty, mineral-rich water from beneath its frozen surface out into space. These environments, cold, dark, ancient, mineral-rich, sealed, look a lot like what's under Taylor's Glacier. Before blood falls, a lot of scientists assumed life required sunlight, warmth, and oxygen. Those were the non-negotiable. These microbes just proved that isn't a requirement, just our version. If life can thrive in pitch black, oxygen-starved saline water for 1.5 million years beneath one of Earth's most hostile landscapes, there is no good scientific reason it couldn't be doing something very similar right now in the ice of another world. Blood falls didn't just change what we know about Antarctica, it changed the entire conversation about what's possible. You know, I spend my days trying to catch something impossibly fleeting. A snowflake has maybe 30 seconds, less sometimes, before it's gone forever. And what I find so moving about this work is that the idea is something this delicate, this temporary can be held. It can be kept. Ice does that. Ice holds things. Blood falls is that same idea on a scale I can barely get my head around. Ancient ocean waters sealed under a glacier for longer than our entire human history. And what's inside that ice isn't just chemistry, it's life. It's adapting, it's going. Ice doesn't just freeze things, it preserves them. And sometimes what it's been quietly keeping turns out to be the most extraordinary thing we've ever found. If you made it to the end of this video, I think you and I are going to get along just fine, because this is exactly the kind of thing that keeps me up at night and makes me love ice and snow and nature even more than I already did. I'm Danielle. I preserve snowflakes, actual snowflake. If you want to see the work, you can find me at PreservedSnowflakeCO or on Etsy. If this gave you a wait, what moment, subscribe. I'll see you in the next one.